Let's do a statics example today, and this one's going to be method of joints. So this is out of the Truss section from the Hibbler book, so that's chapter 6. And this problem happens to be number 5 out of chapter 6. So that first section of trusses. So what we want to do here is we want to find the force in each member of the truss and state if the members are in tension or compression. And this little angle here, theta, we're going to let it equal 0 degrees. So if it equals 0 degrees, then that means this surface here obviously is going to be horizontal like that. So when it says find the force in each member of the truss, usually you're going to do method of joints because we have a lot of forces here to find. And that's just typically the method that we use in statics to find out. All right, now first thing we want to do is recognize that we've got a pin here, and this right here is a roller. All right, so I need to know what's going on at these two forces, or not forces, but these two supports. Okay, so we want to draw our free body diagram, and we're going to draw it of the whole truss. All right, and you can draw an outline of the interior members here if you want. And then let's label our forces. So I've got 3 kilonewtons here, 4 kilonewtons applied down here, and then we've got the pin at A. Now what forces does a pin have? It's got an X and a Y component, right? Because the pin will allow the members to rotate about an axis coming out of that pin joint right here, but those members can't translate. So we got to have an X and a Y. All right, so I just always draw them going positive. And then we've got a roller here. So a roller just basically is like something sitting on top like this. So it's going to keep the member from moving downward. So there's going to be an upward force there. So let's call it CY. And then we can put our distances on here if you really want to make it complete. Okay, so now we've got that. Now notice that we don't have any of the forces inside of the members listed here. And the reason for that is these members are all connected together. So if they're connected together, we've got the equal and opposite reactions caused by, Newton's third law, right? So all of those forces cancel each other out, and that's why we don't have the forces for the members in this diagram, because they're all connected together. All right, so now notice we've got 3 unknowns. We've got 3 equilibrium equations, so we can go ahead and start solving those. So first one, I'm going to do the moment about point A. That will allow me to get CY. All right, and I chose point A because we had 2 unknowns going through that point, so it'll make for an easy equation with only 1 unknown. Okay, so the moment created here by this 4 is going to be a negative moment because it's clockwise with respect to A, and the distance there is 2. So we got negative 4 times 2. We've got this 3 up here. That is going to be a clockwise moment. Distance is 1.5. So clockwise, so it'll be negative 3 times 1.5. And then finally CY, that's going to be a counterclockwise moment, right? Because if you think about it, if I put this here and I push up, it goes counterclockwise. So that'll be positive, and then that distance is 2 plus 2, so 4, set equal to 0. So CY then will be 3.125 kilonewtons. Now let's find AX, AY. All right, so I'm just going to use the Y equation next. So for Y, I've got positive AY minus 4 plus CY equals 0. Now I already know what CY is, right? So we can plug that in. And then solve for AY, and we get 0.875 kilonewtons. Now finally, let's do the X equation. So we've got AX and then positive 3. All right, so now when we solve, AX is going to be negative 3. All right. So now we've got our supports. Okay, so we'll use these as we go through and find all of the forces in the members. Okay, now the way I always do this is I go through and I draw the free body diagrams for all of the joints, and then I look at them all and figure out which one would be best to start with. So that's what I'm going to do here. So let's just start with A right here, and then we'll work our way around this truss. Fortunately, this is a small one, right? We only have 4 joints, so it won't be too long. But these problems can get quite lengthy when they have a lot of different joints. Okay, so joint A right here, let's think about all the forces we have. I know I have a pin, so I know I have this AX and AY. All right, so I know I have that. So I'm going to go ahead and just draw these forces the same directions I had here. All right, so we got our AY. Now we know what AY is, right? It's 0.875. And then AX right here, and that was -3. And then I've got two members attached, right? Well, there's forces in these members, so let's draw forces that represent those members, right? So I always draw the forces going out of the joint, and you'll see why in just a second. It makes it real easy to tell if it's in tension or compression if we do it that way. So let's just say AD is that way, and AB is this way. So notice they're both going out of the joint, and then we need this angle here. So that corresponds to this. All right, so this is 1.5, this is 2. So with that, we could do the arc tangent of 1.5 over 2, right? Because tangent is opposite over adjacent. So if we do that, we get 36.87 degrees. Okay, so we've got two unknowns here. So let's hang on to that. We'll come back to it in just a second. Let's draw the other diagrams first before we do any equations. All right, so point B right here, joint B. So let's draw all the external forces we have. So we got that 4 kilonewtons. And now I've got 3 members attached. All right, well, those 3 members are providing a force on this joint, so we need to represent those. Again, I'm going to put them all going out of the joint. Okay, so we got this one here, which is BC. So it's going to the right to go out of the joint. We've got BD going up. That way it's going out of the joint. And then finally, we've got this one, which is AB. That's going to the left, so it goes out of the joint. Okay. Now notice in doing that, this one and this one are opposite, which is what we need, right? Because we've got that equal opposite reaction. So that checks out, looks good. Okay, so this one we've got 3 unknowns. So let's keep going. Let's do C next. I'll do C over here. So C is right here. And remember we had an angle of 0 degrees, so this roller is really like right on this surface here. Okay. So for this one, we've got our external support, so CY. I'm going to draw it in the same direction I did here. And then we've got the 2 members. So let's draw those going out of the joint. All right, so this will be CD. And this here is BC. Notice again, this BC is going to the left, this one's going to the right. All right, equal and opposite reactions. And then we need this angle. This is the same angle we found up here because this is symmetric here. So we get 36.87. And then lastly, let's do D. All right, so D is this one up here. We've got this horizontal force of 3, and then we've got these 3 members attached, right? So let's put those 4 forces on here. So 3 will go that way. And then we've got AD going down this way, BD, and then CD. Okay. So again, these are all going to go away from the joint. Okay, so now we've got this, and this angle here, let's put this, this is going to be, what angle would that be? Let's see, let's do this one, 53.13, and this one right here. This one right here is going to be 36.87. All right, and we know that one because if this is 36.87, then this one has to be 36.87. All right, so that's how we know that angle, just from geometry. Okay, so now we've got all of our diagrams drawn. We've got the forces labeled, we got the angles. Now what we want to do is figure out which one would be the best one to start with. So for method of joints, if you look, our free body diagrams, we don't have any distances, right? There are no dimensions like meters or inches or anything like that. So that means you can't use the moment equation. So we can only use the two force equations, which gives us two equations, so we can have at most two unknowns and still be able to solve. So I want to pick the joint that has at most two unknowns if I can find one. All right, so that's what we want to look for. So if we look here, D, I've got three unknowns. So I can't solve for anything here because I have too many unknowns. Same thing with B. Now C, I've got two unknowns, so that would be a good place to start. Or if I look at A, I could start here because this one also has two unknowns. Okay, so A or C would be the one we want to start with. I'm just going to go ahead and pick C just because that's what I picked. All right, you could pick A and get the same thing. So let's go ahead and start with C. And we're going to use our equilibrium equations. All right, so on this one, I started with the Y equation. So let's go ahead and start with that. And I chose this one because I would be able to solve for CD out of this. All right, so we got positive 3.125 plus CD sine 36.87. So solve, you get negative 5.21 kilonewtons. All right, now the negative here, since we drew everything going out of the joint, the negative tells us this is compression. All right, so some books will just put 5.21 kilonewtons with a C out to the right here, meaning compression. All right, so if you draw the forces going out of the joint, then anytime you get a negative, you automatically know it's compression. And I'll draw a diagram at the end, and you can see why that is. All right, but for now, negative means compression. Positive will be tension. And I'll show you why in just a second. All right, so effects, we got negative BC, and then negative CD cosine 36.87. Now, we already know what CD is. We're going to use the negative value, don't forget the negative, and then we can solve for BC. And that one, we get 4.17 kilonewtons. It's positive, that means it's tension. All right, so negative is compression, positive is tension, as long as you draw your forces going out of the joint. Okay, so now we've got these values here. What I do next usually is I go through and I fill in these values on the other diagrams where I have these same forces. So CD is negative 5.21, so let's write this in here. And then we have BC, which is right here. Okay, so now we'll look and we'll find another diagram with two or fewer unknowns. Okay, so at this point I could do any of these diagrams. It's not really going to matter which one I choose because they all have two unknowns. So I'm going to go ahead and let's just go up here to A. All right. No reason to choose this one first. That's just the one I chose. Okay, so let's do the X direction here. So I've got positive AX, but the value is negative 3, right? So we're going to have a negative 3 there. Plus AD cosine 36.87 plus AB. So that's going to be 0. So I can't solve yet, right? X equation wasn't the best one to start with. So let's go to the Y equation. And then we'll be able to solve for something. So we got positive AY here plus AD sine 36.87. Now I can solve for AD. And this one I get a negative 1.46 kilonewton. What does the negative mean? Compression, right? So that'll be 1.46 kilonewtons, compression. Okay, now that we know this, we can solve up here. So plug in the negative 1.46, and then get AB, which is 4.17 kilonewtons. Positive, so it's tension. Okay, and then we need to do one more diagram. All right, and I know we only need one more diagram because if we look up here, count the number of members we have. We have 1, 2, 3, 4, 5. So I have 5 unknowns I'm trying to solve for. We have already solved for 4 of them, right? So I only have one more left. So I only need one more diagram. Let's go ahead and label these values on these other diagrams. So we have them. So AB, 4.17, and then AD, which is down here, is negative 1.46. Okay. So you could use either one of these diagrams. It's not going to matter which one you use, but this one's going to be easier because there are no angles. All right, and the only force we need to find still is BD. So this one will be a super easy equation, right? We just use the Y equation. And we get BD minus 4. So BD equals 4 kilonewtons. Positive, so it's tension. Okay, so now we have found everything we need. If you want, you could use this diagram here to check your answers. So do your equilibrium equations. Once you put all the forces and everything in, the two equations should both equal 0 if everything's done correctly. All right. So hopefully that makes sense, the steps we went through. Just draw out the joints, each one. Put all your forces going out of the joint. Make sure you include these external support forces, like the pins and the rollers. And then just pick the one with the fewest unknowns, and then just keep doing that same kind of thing until you find all of your unknowns. Now let's go over why positive is tension, negative is compression. All right. And it might be helpful when y'all are doing these problems to draw one of these diagrams out on your paper so you can actually see what's going on. So let's just go through, and I'm going to quickly draw the joints again and the forces we had. This time though, I'm going to put them in the correct directions, right? Because usually if I have a negative, that means we put the force in the wrong direction. Okay, so instead of this going out, it should be pointing in. So I'm going to switch to the correct directions on this diagram, just so you can see what's going on here. Okay, so joint D we have right here. All right, so I've got a 3 kilonewton. CD, I originally drew it going out. It should be going in because it's negative, so let's do that. And I'm just going to put CD. BD was positive, so we can draw that going down. AD was a negative number, so I need to flip the direction, have it go up. All right, so we got that. Then let's go down here to A. All right, so here is A right here. All right. So we've got this negative 3 here. Let's flip the direction so it's going to the left. Move this up. Whoops, we don't need the negative anymore since we flipped the direction. And then we have AD. AD, if we look up here, I had it going this way, but we found AD to be a negative. So let's switch it. So it's going into the joint. And then we've got AB. AB was a positive, so it should be going to the right. And then finally I have AY. All right, so AY was the 0.875. Okay, now let's do B. All right, so here's B. So BD was positive, we can draw that going up. AB was positive, so it's going to the left. And BC was positive, so that'll stay to the right. And then finally 4. All right, and then finally over here at D. All right, so here was our original D. We've got 3 kilonewtons. AD should be pushing in. Actually, what am I doing? I need C, not D. Oh, wrong one. Let's go right here. Okay, that makes more sense. Okay, so we got CY, which is positive. And then CD was a negative number, right? So I had it going up, so now since it's negative, let's draw it going in, so it's the correct direction. and then BC was a positive. So let's draw it going this way. Okay, so now we've got that. Now we've got these members connecting these joints, right? So let's draw this little green line. It's going to represent the members like that. And let's see why positive is tension, negative is compression. Okay. Well, remember when these interact, like where the members are attached to the pins, you have equal and opposite reaction. So if AD is pushing into the pin, then just because of Newton's third law, we've got the force in the member going this way, right? Going the opposite direction. Same thing down here. This one's pushing into the joint, so the opposite reaction would be to push into the member, and that would be AD. So anytime you have a member, let's just draw a little cylinder here, where we've got forces like that, this is compression, right? So that is why, if we look at AD here, when we got the negative, remember, we had it going out, so that means it should be going in to the joint. So once it's going into the joint, that means it's also pushing into the member here. So that's why the negative gives us a compression. Okay, and then we can do the same thing down here for AB. So this is pushing out or pulling on the joint. So to counteract that, there's a force on the member going to the left. Same thing here. It's pulling on the joint, so the member's gonna push back. So this one, if we look here, we've got forces pulling on the ends of the member. So this is tension. So AB, if we look up here, was a positive number. So this was the correct direction. And then as you see down here, in order to have the equal opposite reaction, there's got to be a force pulling on the member, which puts it in tension. Okay, so that's why positive is tension and negative is compression. And you can go through and keep doing the same things for these. So opposite directions, and then here you want opposite directions, so we'd have forces going into the member. All right, and these are CD, these are BC. Okay, so this one's compression, this one's tension, this one's tension, this one is compression. All right, and you could do one here also if you wanted. All right, so that's BD and then BD to counteract those, right? So this one would be tension also. All right, so negative is compression, plus is tension, as long as you draw your forces going out of the joint. Okay, hopefully y'all like that one. I will see you guys next time. Y'all have a good rest of the day.